Hello, welcome to the course of IPv6. So today we are going to discuss about the transition processes in IPv6. So here in this class we will discuss about the different transition process like the dual stack, tunneling and the header translation. So let's first start with discussing about the transition from IPv6 by IP addresses. So here due to huge number of devices on internet, the transition from IPv4 to IPv6 cannot be happen suddenly. So here to make communication possible between every devices in the network, we need transition from IPv4 to IPv6 address. So the type of transition are dual stack, tunneling and header translation. So let's discuss about this one by one. The first one is the dual stack. So here in dual stack, a router or a host is equipped with both IPv4 and IPv6 protocol version. It means it knows the rule of IPv4 as well as IPv6 addresses. So here the modes of operation exist in dual stack. The first one is IPv4 only node. So here when IPv4 stack is enabled and IPv6 stack is disabled, the node behaves like as IPv4 only node. As and in another IPv6 only mode, here when IPv6 stack is enabled and IPv4 stack is disabled, the node behaves like a IPv6 only node. And in IPv4 and IPv6 node, here when both the IPv4 and IPv6 stack is enabled, the node can use both protocols. So it means the dual stack network is an infrastructure where IPv4 and IPv6 packet forwarding is enabled on a router. So here the advantages and disadvantages exist in dual stack. The advantages are like smooth shift of traffic from IPv4 to IPv6 and no tunnelings or translation is required of the packet, and then best performance, stability and efficiency of a network is in the dual stack transition. And disadvantage of this is that it takes more memory and CPU power as it is to remember the rules of IPv4 as well the IPv6 addresses, and it is a complicated troubleshooting process as if here we need to troubleshoot the router that knows the IPv4 and IPv6 address, that is a complex process. So but the advantages are more than the disadvantages, so we are using the dual stack transition in our network. So here this diagram shows the dual transition. So here a host from IPv4 as well as IPv6 can access the server with the help of dual stack router. So this router is acting as a dual stack router that it's know the rules of IPv4 and IPv6 addresses. So any of the hosts that want to access the server, it can use this dual stack router to communicate with the server as well as IPv4 users. So the dual stack router can communicate with both the network, and router can send and receive data belonging to both protocols simultaneously. The next process is tunneling, and it is also known as encapsulation. So tunneling is a technique in which one protocol is encapsulated in the header of another protocol. It means we are encapsulating IPv4 into the IPv6 address, or if we have to communicate in the IPv4 infrastructure, then the IPv6 address is encapsulated in the IPv4 address. So this is done to make the smooth transition of packet from infrastructure of another protocol. So the component of tunneling process are tunnel management, encapsulation at the tunnel entry point, and encapsulation at the tunnel exit point. So the type of tunneling are manually configured tunneling and the automated tunneling. So these like the manually configured tunneling means here the IPv6 packets are encapsulated in IPv4 packet, and this is done to carry out IPv6 packets on IPv4 routing infrastructure. So these are point-to-point tunnel that needs to be configured manually. Whereas automated tunneling of IPv6 over IPv4 means the IPv6 nodes can use different type of addresses such as 624, 6RD or ISA-TAP addresses to dynamically tunnel IPv6 packets over an IPv4 routing infrastructure. So these are the special type of IPv6 unicast addresses that can be used in some part of IPv6 address field, which can be used to determine the IPv4 address of the destination or tunnel endpoint respectively. Then this diagram shows the transition tunneling technique. That means here there are two users, user 1 and user 2, that are in IPv6 infrastructure, and they have to communicate together, but in between there exists a IPv4 infrastructure. So user 1 sends IPv6 packet to router A, and this case router A acts as a tunnel entry point, and it encapsulates the IPv6 packet in an IPv4 header and sent to the router B. And in this case, router B acts as a tunnel exit point. It strips off the IPv4 header and forward the packet to the user 2. So in this way, they communicate with each other by existing in between the IPv4 infrastructure. So this is a tunneling process where we are tunneling the IPv4 infrastructure to communicate to make communication between the two IPv6 users. Next is tunneling. Here IPv6 packet encapsulation steps are like: at entry point of the tunnel, the device will decrement the hop limit value by 1 and then encapsulate incoming packet into the IPv4 header. An encapsulated packet transmitted to the tunnel and fragment IPv4 packet, and here the fragmentation of the IPv4 packet is done if necessary. Next is exit point of the tunnel. Here what happens, it receives the encapsulated packet, checks the source of the packet, and then if the packet is fragmented, it will resemble it at the exit point. And it will remove the IPv4 header and send IPv6 original header to the destination. The next part is header translation. So here in a network, when a transmitter device transmits a packet in IPv6 format and receiver still works at the IPv4 format. It means the one that is sender is using a IPv6 format, whereas the receiver is using a IPv4 format. So here we will use the header translation process. So then the tunneling technique will not work here. So header translation technique is used in which header of the IPv6 packet is converted to an IPv4 packet. So header translation uses the mapped address to translate IPv6 to IPv4 address. So here in this diagram, you can see here we have used the header translation device in between the IPv6 and IPv4 host. So as IPv6 want to send something to the IPv4 host, so here the header translation will convert or map the IPv6 packet into the IPv4 packet. Then there is a process known as NATPT, that stands for Network Address Translation Protocol Translation. So this is process that we are using in IPv6, but NAT is used in IPv4 addresses. So this is protocol translation mechanism done in two direction, and here the static NAT defines in one-to-one mapping from one IP subnet to another IP subnet in each direction. So NATPT binds the addresses in IPv6 network with addresses in the IPv4 network and vice versa. So to provide transparent routing for the packet traversing between the address region. So here the advantage of these are, and device and network can choose any address, either IPv4 address or IPv6 address, and traffic run from any side of the network. So the mapping included destination IP address translation in one direction and a source IP address translation in the opposite direction in the protocol translation mechanism. So these are the two directions associated in NATPT, that is the destination IP address translation and the source IP address translation in the these two particular directions. So this is all about the NATPT. So this all about the transition of IPv4 address to IPv6 or IPv6 addresses to the IPv4. Thank you.